This video is a basic look at addition and multiplication on mechanical calculators. It's beyond the scope of the video to dissect the mechanism of the machines. However, I've linked a video in the description that does an excellent job of breaking down the pinwheel mechanism. While not all mechanical calculators use the exact same mechanisms, they all work to give the same result. I've also briefly covered division on the Facit STW10 in a previous video, linked in the description as well. To start, let's look at how we do some basic calculations on paper. First, we can do 12 plus 12. However large the numbers are that are being added together, we break down the whole operation into single-digit additions. In this case, we add 2 plus 2 and get 4. Then 1 plus 1 and get 2. 12 plus 12 is 24. We can also express this as a multiplication operation. Multiplication is really just a shortcut system for repeated additions. Similar to addition, we're breaking down the multiplication into single digits. 2 times 2 is 4, 2 times 1 is 2, and the answer is again 24. On the mechanical calculator, we start by inputting our first number, 12, to the setting register, and then adding it to the accumulating register with the turn of the handle. We can see how the digits of each number stay in alignment on these two registers, and we can see the count register has turned over one time. 112 is 12. Since our next number is the same, we can simply repeat the operation. We can see that adding 12 to 12 is 24, and the count register has advanced. Because both numbers we used are the same, it shows that 12 times 2 is 24. Let's take a look at 12 times 10. We know that multiplying by 0 results in nothing, so we can skip that step. When we multiply by the 1, we are really multiplying by 10, so we start by placing a 0. Then it is simply 12 times 1, which is 12 again. So 12 times 10 is 120. On the mechanical calculator, we can do this as an addition. Enter 12 into the setting register and add it 10 times. If we slow down at the 10th addition, we can see the 1 carry over in the accumulating register and count register. 10 additions of 12, or 12 times 10, is 120. The calculator allows us to do this much quicker, however. With 12 in the setting register, we can shift over one digit and do one addition straight to the tens place. This is just like how we skipped the multiplication of 0 when doing this on paper. Let's combine the two previous examples and do 12 times 12. 2 times 2 is 4. 2 times 1 is 2. We've moved up to the tens place, so we start by placing a 0. Then 1 times 2 is 2, and 1 times 1 is 1, for 120. You can see that we now have the two results from our previous examples, and we add these together. 4 plus 0 is 4, 2 plus 2 is 4, and then 1. 12 times 12 is 144. Going back to the calculator, with 12 in the setting register, we add 2 times and get 24. Then we shift over one digit and look at how the numbers line up. We're now adding 120 to the 24 already in the accumulating register, and looking at the count register, we can see that 12 times 12 is 144. Subtraction is just this process in reverse. We can take 120 away, and we're left with 24. Shift over and take away 12, and we're left with 12. And then once more, and we have 0. On the Facit, multiplication is handled with a separate keypad and register. We'll use the number 12 again, but let's multiply it by 99 so it's easier to see what's happening. We can see the machine uses the multiplication section as a counter to keep track of how many times it repeats the operation. When it counts down to 0, it shifts over to the next digit, both in the multiplication register and the accumulator up top, and counts down again. When it runs out of numbers to count down, it stops. This is also why the number from the multiplication register ends up in the count register when the operation is done. And we can see that 12 times 99 is 1,188. This is a fairly brief look at the functions of a mechanical calculator, but I hope it gives an understanding of how the mechanisms are just a recreation of our workflow when doing the calculations by hand. Thank you for watching.